All right, how are we today? Another video here. We're going to continue to work with areas of our shapes, rectangles, squares, triangles, parallelograms, and maybe a little bit of trapezoids. But today we're going to review. We're going to have some, you're going to have some review problems on your homework, of course, to continue your skills with finding the area. But also, we're going to try a few more kind of extension problems. Okay, but first, as a warm up, I want you to try these problems. Now, this won't seem like it has anything to do with what we're doing lately, but it does. Okay, so what I would like you to do, here's our warm up. I want you to solve these equations. Okay, so number one, 3x is equal to 18. And remember, that's the operation. There's multiplication. So to solve it, we're going to divide both sides by 3. Okay, number two, how about 6x is equal to 72. Let's try that. And how about number 3? Let's try a fraction one. 1/2 x is equal to 24. And number 4, how about this one here? Let's try a division problem. I'll use a this time. A over 4 is equal to 17. So you're going to solve that one for A. And I think I'll put number 5 down here. Okay, another division one. How about y over 3 is equal to 7? So think back. When we were doing division problems and division before, we'll go ahead and solve those. Okay, so I'm going to wait a minute. So you should put the video on pause. Get some paper and try out these warm-up problems to solve these equations for x, because we're going to use this on today's lesson. Okay, ready, go. Okay, well, I assume you're back now, having worked on and solved those equations. So here's how we would do this one. For this guy, we're going to divide both sides by 3. We're multiplying by 3, so we're going to divide both sides by 3. X is equal to 6, because 18 divided by 3 is 6, right? Over here, number 2, we're multiplying by 6, so we divided by 6. 72 divided by 6 is 12. You can do these operations on your calculator if you want. Okay? So, number 3. If it's a fraction in front, remember, back, what we did was we multiplied by the reciprocal of 1/2, which was 2 over 1. And we multiplied by 2 over here, which is the same thing as 2 over 1. That caused the fraction to cross cancel. So we still have x by itself. 24 times 2, 48. Okay? In this equation, we say, oh, look, we're dividing by 4. So we're going to multiply both sides by 4, which is the opposite of dividing by 4. Okay? Now that caused, dividing here, multiplying here, still caused the two operations to cancel. We've got A, and then 4 times 17, as it happens, is equal to 68. Again, you can do that on your calculator. This guy here, we're dividing by 3. So what did we do? We multiplied both sides by 3. That caused the multiplication and the division to cancel, isolating the y. 3 times 7, 21. Okay? So anyway, so that's a warm-up. What we're really doing here, so that's our warm-up. I'm going to put that aside here. Okay? What we're really doing here is we're going to solve for dimensions of shapes given the area, right? So for instance, let's say we had a rectangle like this. Here's our rectangle. This is going to be example 1, right? Just like that. Okay, so let's say this was 10, and then the width was 8, right? So we had a rectangle whose length was 10 and whose width was 8. Now remember, for rectangles, our formula was the area was the width times the length. So if we wanted to know what the area was, what we did was we multiplied area was, and by the way, we also had dimensions. So let's say it's 8 inches by 10 inches. We multiplied 8 times 10. We multiplied 8 times 10. That's equal to 80. Inch times inch, since it's area, that's going to be square inches, right? So our answer is 80 square inches. Now, so that's something we did on previous homeworks, and I hope that looks familiar to you. Okay, but let's say we had this. So this is all going to be part of example 1 here. Let's say we had the same rectangle, but we had a different set of information. Let's say I happen to know that the width is, that the length down on the bottom, let's say I happen to know that that's 11 inches. And let's say that I happen to know that the area is, let's say 99 square inches, right? How much would the width have to be? Well, in order to figure that out, we're still going to use the same formula, because the length times the width, whatever it is, would still have to multiply to give you 99, right? So I'm going to write the information over here. The area is equal to 99 square inches. We know that the length is equal to 11 inches. How much is the width? Okay, well, we've kind of recorded all the information and we've got a picture to look at. We're going to use this formula. We're going to take these numbers, 99 and 11, and plunk them into the formula where they would be. So 99 goes where the area is. 11 goes where the length is. W, we don't know. That's the width, right? So oopsie, I didn't even write it in. All right. The length is 11. Okay, so 11 goes where the length is. W, we don't know what it is, so it stays W. 99 is the area. Now we rearrange that a little bit to put it in algebra terms. 11 times W, we're going to write 11W. 99 we put on the right side because we're used to seeing the variable on the left. Now we just go ahead and we solve the equation like we were just doing in a warm-up. We're multiplying by 11, so we divide by 11 on both sides. That cancels out, isolating the W there, and 99 divided by 11 is 9. And since the units are inches here, that's going to be 9 inches. Okay? So that's kind of what we're going to get at. We're going to have various problems here. We're going to be given the area in one of the dimensions, and you're supposed to solve an equation to get the other dimension. So let's try. So this is going to be example 2. So let's do example 2. You do example 2, and I'm going to draw the picture. We'll do example 2 together. Sorry about that. We've got a rectangle here, and I happen to know that the area is 120 square feet. And let's say I know that the width is equal to 10 feet, right? How much, I'm going to move this up a little bit, how much would the length have to be? Well, over here, we're going to record the information. the area is 120 square feet. The width now is equal to 10 feet. We want to know what's the length in terms of feet. Well, we're going to go back and use the same formula. Area is length times width. Put 120 where the area number goes. Okay, L we don't know, so I'm going to put that just right L. The width is 10, right? So 120 has to be L times 10 times whatever L is. We rewrite that algebra-wise right here. 10L is equal to 120, where we've got the variable on the left side of the equal sign. Now you can see here, we divide by 10, divide by 10. Length, 120 divided by 10 is 12 feet. So here's our steps. Make sure we record the information, including what the unknown is. We take our values and our variables that we're given, and we plunk them into the area formula. Over here, we rearrange them algebraically. Right? Sorry, you couldn't see that. There's supposed to be 120 there. We rearrange them algebraically, and then what that leaves us with is an equation we already know how to solve. We're multiplying by 10, so we divide both sides by 10, and the correct dimension, 12 feet for the length, falls out the bottom. Okay? So now, why don't you go ahead here? Why don't you go ahead and try? Well, we'll do one more. Okay. Make sure here's the rectangle. I think I'll arrange it kind of up and down like that. I'm going to tell you that on this one, the length is going to be equal to 7. We want to know what's the width. Okay, the width looks longer than the length, but it don't matter, right? And I'm going to tell you that the area is going to be 84, and these are going to be inches. 84 square inches, and then that length is 7 inches. Okay? So, the area is 84 square inches, right? The length is equal to 7 inches. The width is the one we don't know. So what do? Well, okay, using our formula, area is equal to length times width, right? We know that 84 has to be equal to 7 times W, right? So now we rearrange that algebraically so that we've got 7W is equal to 84, right? Divide both sides by 7 to get the W by itself, and so that gives us 84 divided by 7 works out to be 12, and it's going to be 12 inches because those are the units that are in the problem. Okay, so hopefully that is going to work for you. Okay, now here, oopsie, got my hand anywhere. You try this one. I'm going to give you a rectangle here, and I'm going to tell you that here's the length and the width and the area. It's not a very good rectangle. Just pretend that's a rectangle. Okay. I'm going to tell you that the area is 56. I'm going to tell you that, let's say square meters. I'm going to tell you that the width is, let's say, 7 meters. What would the length be? Okay. So try this. Put your video on pause and try this problem just to make sure you know what you're doing, and then we'll move on, okay? Okay, so we're back. Hopefully you tried that, okay? The area is 56, so we put that in the area position where the area is, because remember area is length times width, so 56 goes into the area position. 7 goes into the width position, so we've got L times 7, right? So we've rearranged that algebraically. 7L is equal to 56. Divide by 7. L is equal to 8. And it has to be 8 meters because the units we're working with in the earlier, in the other parts are meters. So we're dividing by 7 there. Okay? All right, very good. Okay, so we'll spend another, I think we're going to split this up into 2 videos, so you don't have to sit through too much here. Okay, so we just did rectangles. Hopefully you're okay with that. Now we're going to try the same thing, but with parallelograms. Okay, so let's say, so here is a parallelogram. Remember, that's a shape with 4 sides. Opposite sides are parallel, but the angles between the sides aren't 90 degrees. Okay? And remember how we found that area. We had the height, we had the base, and then the area was equal to height times base, right? H times B. So, for instance, if we happen to know that the height was equal to 10 and the base was equal to 15, then the area would be 10 times 15, which is 150, right? Okay, so what if we had this problem here? We're about on example 4 right now, I think. So let's see here, example 4. What if we had this parallelogram here? Okay. Just like that. And I happen to know that the height is 3, and let's say the area is equal to 54, and I better have some units here. 54 inches and 3 inches, that's the height. Okay? We don't know what the base is. Remember, by the way, in parallelograms, the height is that distance between the 2 bases. Okay? So, over here, the area is 54 square inches. The height, that's 3 inches. What's B, the base? Well, we put 54 where the area is. B where the base is, because we don't know what it is. 3 where the height is, because we're told that the height was 3. Now we rewrite this algebraically. 3b is equal to 54. Now again, it's just a simple little one-step equation to solve. We divide both sides by 3, right? And we get b is equal to 18. In this case, 18 inches, because the units to start with were inches. Okay, here is a example 5. Here's a parallelogram there. And I'm going to tell you that this distance there, let's say that's the height. And at the length of the base is, let's say, 62 yards. It's a big parallelogram. And we're told that the area is, on here, 1,027 square yards. Right, now, here's the thing. Remember how parallelograms work. Okay, remember the height of the parallelogram is the distance between 2 parallel sides. So that's why here we could measure the height across like that, because it's called the height, which makes it sound vertical, but really it's just the distance, that vertical distance between 2 sides. So anyway, so on there, let's pretend, so we're told that the base is the side that height connects. So here, the base is going to be 62, the height is 1,027, right? Well, right? area is still base times height, so it's going to be 1027 is going to be equal to 62 times the height, which we don't know, right? Now, rearranging that algebra-wise, 62h is equal to 1027. Divide both sides by 62. And we get h is equal to, consulting Mr. Calculator here, and that's 16.6 yards. Okay, and then by the way, that 16.6, I rounded off to the tenths place because it's got, if you divide it out on your calculator, which you should try these yourself to see, make sure they're working out the way you understand what I'm doing here. Okay, it works out to be, there's a whole bunch of repeating decimals. So I just rounded it off to the tenths place, 16.6. Okay, all right, now, so you go ahead, you try. Okay, so you're going to try these. Okay, let's say we've got a parallelogram. And this will be number 1 on the try these for parallelograms. 127 is going to be the area, right? And then I'm going to tell you, it shows there that the height is equal to 15.5. How much is the base going to be? Well, the area is 127, right? The height is equal to 15.5, right? So therefore, and we want to know what the base is equal to in terms of centimeters. So our formula is still area is equal to base times height. So we put area 127 where the area is, 15.5 where the height is. So it's 127 is equal to base times 15.5. We rearrange that algebra-wise. 15.5b is equal to 127, and then we divide both sides by 127, and we divide both sides by 15.5, and we get 254, we get about 8.2. Now, I guess I didn't give you a chance to try that one, so you're going to try this one right here. Okay, so here the area is going to be 22. The base is going to be 16, so that number that's supposed to be. What's the height going to be? So hit the pause, try that out. Okay, good. So the area is, well, still using this formula here, we put 22 where the area is, 16 where the base is, h, the unknown height. So rearranging it, 16h is equal to 22. And that's, height is 1.375 inches. And that's our that's our dimension. The height has to be 13.375. Okay, slide that up so you can see it better. Okay, very good. So I'm going to stop this video here. When we come back, we're going to go ahead and we're going to have some problems involving circles and triangles. Okay, and so that's when we come back. That'll be video part 2. Stay tuned.